Hey, hi. Today it's going to be another TryHackMe walkthrough video. If you see my previous videos, you will see more TryHackMe related some guided exercises. For the time being, I'm making this kind of videos. I'm also trying to spend some time on some new concept learning because as long as I learn some new quality concepts, I'll be able to deliver some quality videos. So that is where I'm currently heading. And today it's a TryHackMe walkthrough, as I said, and the concept is Linux forensics. If you are in a cybersecurity, especially on the blue team side, then you might have seen this kind of Linux stuff, the Linux operating system often, because you cannot simply ignore Linux when you are especially in the security field. And if you see the server operating system, most of the server operating system market being held by Linux operating systems compared to Windows. But if you see the client endpoints, the client operating systems on a typical PCs and laptops, it will be Windows. Mostly Windows is holding its market, but the server you cannot ignore. It will be like the Linux operating system. And if you see the Android operating system, the base for the Android OS is Linux, and for the Mac also the same story, so you cannot simply ignore. So understanding the Linux operating system and knowing where to look when any incident happens on Linux operating system is a vital skill to have. So that is why I chose this specific room. So without wasting further time, let's begin. Yeah, here is the TryHackMe room, Linux forensics, and the TryHackMe gave their Linux machine to take this exercise, and I connected on the TryHackMe VPN. Hence, I got this IP address, and from here, from this VPN, I'll be able to reach the TryHackMe given machine. And yeah, let's start this exercise. Learn about the common forensic artifacts found in the file system of Linux operating system. And that is the one line for this exercise. So let's move on to the introduction part. In the previous few rooms, we learned about performing forensics on Windows machines. Even I made few videos about the Windows operating system forensics, like forensics on the registries and collecting some crucial files from the Windows C drive and all. So you can view those videos in my channel. I'll be putting those links in the description so you can refer those. While Windows is still most common desktop operating system, especially in the enterprise environments, Linux also constitute a significant portion of the pie. Especially Linux is very common in servers that host different servers for services for enterprises. As I said before, Linux is very common in the server operating systems. When any threat actors, adversaries target any enterprise, they will be focusing on servers rather than the user endpoints, because servers will be often having some crucial stuff, crucial information. So learning about the Linux forensics is more important than learning the Windows forensics. Obviously, both are important, but Linux has an edge compared to Windows operating system. In an enterprise environment, the two most common entry points for an external attacker are either through public facing servers or through endpoints using by individuals. Since Linux can be found in any of these two endpoints, it is useful to know how to find forensic information on a Linux machine, which is the focus on this room. All right, let's see the learning objectives. After completing this room, we will be learned these steps. I mean, these things. Let's see what are all those. Introduction to Linux and its different flavors. Okay. Finding operating system, account, and system information on the Linux machine. All right. Finding information about running processes, executed processes, and processes that are scheduled to run. Then finding system log files and identifying information from them. And finally, common third-party applications used in Linux and their logs. All right, this is just an information, the specific part. Moving to the next part, Linux forensics. And here, the Linux operating system can be found in a lot of places. While it might not be easy to use as Windows or Mac OS, it has its own set of advantages that makes its use widespread. Compared to the other operating systems like Windows and Mac OS, those operating systems are very popular among the end desktop users because they are user friendly. But Linux is not like that. You need to have some patience to access this Linux OS. And it is found in the web servers you interact with in your smartphone. As I said, Linux is the base for the Android operating system, and maybe even in the entertainment unit of your car. One of the reasons for this versatility is that Linux is an open source operating system with many different flavors. It is also very lightweight and can run on very low resources. It can be considered modular in nature and can be customized as per the requirements. See, lot of advantages of using Linux operating system. That is why it is actually leading in the operating systems market, meaning that only those components can be installed which are required. All of these reasons makes Linux important as part of our lives. Actually, Linux kernel, I mean, every part of Linux is freely available. It is open source, so even you can, if you think you can able to build your own Linux operating system, it is very easy. You can simply download a Linux kernel. You can add additional parts with that Linux kernel. You will be able to make your own operating system. So that is why people make a lot of Linux distributions. Among those bunch of distributions, few distributions are very popular, and we are going to see those distributions. Linux comes in many different flavors, also called distributions. So that is the term to denote each and every type of operating system. There are minor differences between these distributions. Sometimes the differences are most cosmetic, while sometimes the differences are little more pronounced. So here you can see some common Linux distributions. Ubuntu is one of the popular distributions in the Linux desktops, and Red Hat commonly used in the Linux servers, and it's a paid operating system. You have to pay to Red Hat to purchase this operating system, and also they offer some reliable support for this operating system. And Arch Linux is another open source Linux distributions. OpenSUSE is also a Linux open source distribution. Linux Mint, same as Ubuntu, Arch Linux, and OpenSUSE, an open source distribution. CentOS is an open source distribution. Debian is also an open source distribution. There are a lot more customized Linux distributions are available. For the purpose of this room, we will be working with the Ubuntu workstation. So this particular machine is an Ubuntu machine. So on this machine only we are going to take our exercises. So this is another information. Can you tell which distribution is presented by which logo in the image? So by seeing this logo, you should be able to spot the Linux distribution, what Linux distribution it is. That is what they gave. Red Hat, Arch Linux, OpenSUSE, Linux Mint, Ubuntu. All right, moving to the next one. So this is where the main topic begins. You have to start the machine. I already started and opened it. So as we did in the Windows forensics room, we will start identifying the system and finding basic information about the system. In case of Windows, we identified the Windows registry contains information about Windows machine. For Linux system, everything is stored in a file. So this is another major difference between Windows and Linux. If you see the Windows operating systems, there is a separate part called registry where every crucial information is getting stored. You'll be able to modify any kind of system settings from the registry. But Linux, everything is file. It's a file system. So everything is stored within a file. So that is what they gave here. Therefore, to identify forensic artifacts, we will need to know the locations of these files and how to read them. Below, we will start identifying the system information of the Linux host. So let's begin. So this is just a guide to start the machine. We already started it, so it is no longer required to us. And moving to the next topic, OS release information. So we need to understand what kind of operating systems we are on. Especially when you are performing forensics, you might not be having an idea on which kind of distributions you are on. So to find those, these are the commands you can use. First of all, the cat is an utility to read the content of a file, and here is the file. It is located in the HC directory of Linux, and OS release is the file that you want to look on. So let's try to look at this on our machine. I'm using cat utility space HC OS release. So here we are. We got the information about the system. It's a Ubuntu operating system, and the version is 20.04 focal fossa version. And the ID like Ubuntu. So here they gave the version once again and some URLs related to Ubuntu, and the version name, version code is focal. So that's what they gave. So this is how you have to spot the operating system, the the distribution type, and that's what they gave here. And if you want to see the user accounts, who are all the users who are accessing this specific machine, then you need to look at the specific file, HC password. This is a very popular and common file among the ethical hackers and cyber defenders. So let's look at this content, HC passwd. So here is the content. So once you apply this command HC password, you will be able to see the list of users, the list of user IDs available on the system. And at the top, the root user, the administrator in every Linux system is given. And if you scroll down further, at the bottom, you can see the user created, the manually created user ID, and the user ID is TryHackMe. So through this user ID only, the machine is getting accessed often. And you can see there are a lot of other user IDs. These are the IDs getting used by various system services that are running on this operating system, this machine. And this is for some machine usage. And the TryHackMe is the user ID created by a human being manually created. So that is why we are focusing on this one. And you can see the shell, actually it is a bash shell. Bash shell is usually usually used to interact with the operating system by the users. And here you can see the contents of the file etc password, and the etc password file contains the information about the user accounts exist on a Linux system, as I said before. And we can use the cat utility to read this file. All right, the output contains colon separated fields describing username, password information, user ID, group ID, description, home directory information, and default shell that executes when the user logs in. It can be noticed that just like Windows, the user created user accounts have UIDs 1000 or above. You can use the following command to make it more readable. So here they are suggesting this command to format the outcome. It will give some better format to read this. So let's try this. Why don't we try this? All right, let's look at this. So here is the better view of the file content, and you can see the username TryHackMe, and the password is given in X. Because the password is not stored in this HC passwd file, it is being stored in another file called HC shadow. And you can see the user ID 1001. This is the first user ID manually created on this machine. That's why it is the user ID is above 1000. And you can see the group ID same as the user ID. And the TryHackMe, I think it is a group, and you can see its home directory. So whenever the user logs in, the TryHackMe user logs in, he will be landed in this specific directory only. And the bin bash is the default shell being used by the user, TryHackMe. And moving down further, you can see the same stuff that I explained shortly before. The password information stored as X on the HC password file, because the password is getting stored on this specific file, HC shadow. So protecting these two files is very important. And let's try to read the content of the HC shadow file. So permission denied. I don't have the permission to read this file. Anyway, let me check further. You can see another stuff here. To find the group information, the list of available groups on any machine, you can able to use this specific command. I mean, this is the file actually, the file group present in the etc directory, and you can cat this file results. So let's try that. Cat etc group, and here you can see the groups available, and the group called TryHackMe. When you are creating any user, typically the group ID will be same as the user ID. So that's why when you create the user called TryHackMe, even the group name is TryHackMe created. And scrolling down further, we can see the user Ubuntu belongs to the ADM group, which has the password stored in HC shadow file signified by the X character. So when you can see this X character, then you can assume the password for this specific user ID is getting stored on the HC file, HC shadow file. And you can see the group ID is 4, and the group ID contains 2 users and the syslog. Yeah, so the GID is 4 and the group contains 2 users, syslog and Ubuntu. You can see this specific stuff, this specific entry where the group ADM has 2 users, syslog and Ubuntu. So that is what they are denoting here. And you can see another interesting thing, pseudoverse. Pseudover means, I mean, the pseudo means what super users do. So it gives the super user privilege for any normal Linux machine user. So it has to be, the pseudo privilege has to be given exclusively. And once they, I mean, once the administrator gave the pseudo privilege to any specific user, then those details can be viewed in the specific HC pseudoverse file. So let's look at this. Not sudo. I'm simply catting this HC pseudoverse file outcome. Permission denied. I don't have the permission, but I can use sudo, I guess. First of all, let me verify my sudo permission. To verify the sudo permission, you have to use sudo -l. Then you will be able to see the sudo permission that you are having. You can see this word all, and this is nothing but this specific user Ubuntu is having the pseudo privilege. So let's try to read this content pseudoverse with the help of pseudo privilege. Cat HC pseudoverse, and here is the outcome. Root user is having obviously all privilege, and percentage admin is having all privilege. Percentage sudo is also having all privilege. Yeah. So here is the content of pseudoverse file. Let's use this sudo privilege to view the shadow file content. So here you can see, as I mentioned before, the password hashes are getting stored for every user in this shadow file only. For example, you can see this TryHackMe user, and the password is stored here. So this is the password. Before this colon, everything is password. All right. Moving down further, let's see the login information. And this is a vital thing in forensics, Linux forensics. If you're doing any forensics, you cannot simply ignore this specific path /var/log. So this is where the every crucial logs are getting stored. In this directory, we can find log files all kinds, including wtemp, btemp. Btemp file saves information about failed logins. So here they gave the definition, the use case of each file that is present in this var log directory. And you can see the WTMP, it keeps the historical data of logins. And these files are not regular text files that can be used, I mean, that can be read using the cat. Instead, they are the binary files which have to be read using the lost utility. So there is an utility called lost. So we have to use this utility instead of using this cat and other text editor, because when you try to read these contents with the cat or other text editor, you won't understand anything because it's a binary. And that is why they are suggesting us to use this last utility. And you can see the last utility additional parameters and commands with the help of its man page. And here you can see the way how we can use this last utility to read the content of any file. And let's see this one. Um, let's try this btmp file. Obviously it stores the failed login attempts. So let me try to use this last utility to read this file btmp. Here they did for wtmp, but I'm doing this for btmp. All right, now since we are reading some crucial files, we are using the pseudo privilege, and the utility is last and -f, where log btmp. So let's try to read this. So here is the outcome. So this file actually having all the failed login attempt data. So here you can see who tried to log in this machine and what time they tried and the date, and you can see everything here, the username and all. So this is the interesting thing about this utility. But let me try to read this file, the same file btmp, with help of the text editor or a cat command simply. So let's see what happens. And I'm catting. Bear with me, this machine is dead slow. Log btmp. So I'm simply catting this file content, and I'm using less to show only few stuff. What happened? I don't see anything. Permission denied. So let me use sudo to run the same command with super user privilege. What happened? Yeah, here you can see the content. Though it is showing some human readable words, still this string is non readable. This is a binary. So that is why they are suggesting to use the utility last. All right, moving to the next one. Authentication logs. Every user that authenticates on Linux host is logged in the auth log. So when you are logging into the Linux distributions, it will be logged in this auth.log file. And the auth log is a file placed in the specific same, the var log location. And it can be read using the cat utility. So unlike this WTMP and BTMP, this auth.log can be viewed by using the cat utility or any text editor. But however, given size of the file, we can use tail, head, more or less. So these are the keywords, these are the utilities we can use to shorten the file outcome. So you can see specific part of the output. In the above log file, we can see the user Ubuntu elevated privileges on this specific date. So let's see where it is given. So here you can see the specific stuff. The user Ubuntu actually elevated their privilege to, their privilege using command called sudo. Yeah, that is what they gave. They used sudo to become root. Yeah, that is what we can understand by seeing these three lines. All right. Yeah. So it's a kind of a privilege escalation. And let's try to answer these questions. In the attached VM, there is a user account named TryHackMe. What is the user ID of this account? So let's try to get the outcome of the pass WD file once again. And here they gave the user ID, it is 1001. That must be the answer, 1001. Yeah, that is. And which two users are the member of group audio? And here for that, to get this outcome, we need to use the cat HC group. We need to view the group file. And here we need to look for the user, I mean the group name audio. So let's try to look for that. Yeah, here you can see one user is Ubuntu, another user is Pulse. So let's try to answer that. Ubuntu and Pulse. That must be the answer. Yeah, that is. And a session was started on this machine on Saturday, April 16, around 10:10. Okay. How long did the session last? So let's see the hint here. Actually, they are recommending to use the WTMP. TMP. Actually, we have to view the content of WTMP. For that, we have to use the utility last. And I'm using sudo privilege and last command and hyphen f and then the file name log then WTMP. Exactly. Yeah. Now, what is the question? Saturday, April 16, 20, I mean 10:10. April 16, Saturday, 10:10. And here you can see the session lasted. Actually, it lasted around 1 hour 32 minutes. So that is what they are asking. You can see the from time from 10:10 to 11:43. This specific session was alive. So let's copy this and paste this. I think, yeah, I'm able to paste. Yeah, with this, we finished off this part. Moving to the next one, system configuration. Let's see what we are having here. Yeah, a lot of details. System configuration. Once we have identified the operating system and the account information, we can start looking into the system configuration of the host. To view the host name of a machine, you need to see the specific file, HC host name, or you can simply use a command host name that would display the host name of the machine. Yeah, and I'm simply catting the HC the hostname file just to show the same stuff. Yeah, the same thing. And moving to the next one, the time zone. The time zone information is a significant piece of information that gives indicator of general location of a device or the time window it might be used in. So by seeing the time window, you'll be able to get an insight about the device location. And also when you are parsing the logs, the time will be very very important. At what time the specific incident took place, if you want to know the detail, exact detail, then you need to make sure the time zone on which the system is running. So here you can view the you can view the time zone details with this same HC located time zone file. And let me read that file. Time zone. Yeah, actually the device is running in, it is running from Karachi, Pakistan, and it can be read using the cat utility. Yeah, exactly, we did that. And the network configuration. And to view the network configuration, information about the network interfaces present on the system, you need to use the cat utility, and the file is HC network interfaces. The output on your machine might be different from the one shown here depending on your configuration. Since it is a network related info, it will be differing machine to machine. So beware while you are looking at this file. So catting that file, HC network interfaces, I guess. Yeah, interfaces. So here you can see the list of network interfaces. All right. And moving down, similar to the to find information about MAC and IP address of the different interfaces, we can use the IP utility. Yeah, so that is another utility they are suggesting. IP address show. So this is the utility typically we use to witness the IP address of the network interface. IP ADDR also you can use. IP space ADDR. So here you can see the list of interfaces and its IP details and MAC details. So here they gave the MAC address of the specific interface and the IP address specific to that interface, and the loopback interface located in every machine. It's a local interface. When you are forwarding any traffic to this specific IP, it is simply you are forwarding within that system. It is local to the specific device. When you are forwarding something to this interface, it will not go out. So that is the concept. And scrolling down, active network connections. Yeah, this is another important command to know, because the netstart command is very vital when you are doing some network forensics. And you can also see the man page of the netstat utility to use this netstat utility in more better way. But for as of now, for the time being, we are simply using this command netstat hyphen natp. So let's use that netstat hyphen natp. So here is the list of available connections. You can see the connection state. What are all the ports listening on this machine, and what are all the ports already established on this machine. So these are the stuff. Now we are seeing this machine on the VNC, right? So Tiger VNC is being used. So that is why it is showing the Tiger VNC connection. It is live, established. And scrolling down further, so here is the utility to view the running process on Linux machine. And the use, and I mean the utility is simple. PS, only two letters. So that is the utility to view the running process on any Linux machine. So here you can see the running processes present on this machine. And let's use the PS space AUX as given in the exercise. So here you can see the detailed view of the running processes. And actually it will give the user who is running the process ID, percentage of CPU and memory utilized by the process, and when the time when that process started, and also the commands related to that process. Very impressive. This command ps space aux, and ps space aux, I'm piping it to show the less outputs, and here I can see the limited output, and the command sbin init rcuk worker. These are some system binaries. I mean the system process. You can see the Python process here. The Python 3 is running, and the cron process for the cron tab, cron jobs, and some kernel processes I can see, and one more Linux process, one more Python process. Sorry, um, rolling down, rolling down. There are a lot of processes running at the backend. Yeah, and to see the DNS information, you have to view the content of the etc host file. So that is where the DNS info is getting stored. etc hosts. And here you can see the DNS info. So this is like making a static DNS entry. By default, there is a static DNS entry for the loopback address. But if you want to make any static DNS entry, then you can make here in this etc host file, and you have to be an administrator or you have to be with the sudo privilege to make changes on this file. And here you can see the information about the DNS servers that Linux host talks to, or the DNS resolution is stored in the resolve.conf file. In the previously on the host file, we have witnessed the DNS entry, but here you can see the resolve.conf file, which is where the DNS server related informations are present, and we can simply cat that file contents as well, resolve.conf. So let's see the DNS server. So here you can see the DNS server details. And what is the host name of the attached VM? We have already seen this. Let's execute the command host name once again to get the host name of the system. It is Linux 4N6. Yeah. And what is the time zone that the attached VM present? It is Asia Karachi. We have already seen this. Yeah. And what program is listening on the address 127.0.0.1 and 5901 port? And we have to use the netstat utility hyphen natp, and you can see the local address, it is listening on 5901, and the utility is x tiger vnc. So that is the utility. So let's try to answer this. Yeah, that is the answer. And what is the full path of this program? They are also asking the full path for this program. And to get the full path for this program, let's see the hint: psaux, and we are gripping the x tiger vnc utility. All right, I got this. So I'm using psaux and I am piping grep the x tiger vnc. Yeah, so here is the full path: usr binary x tiger vnc. So that is the full path for this specific utility, and I think that is what they are asking. Yeah, that's the right answer. And read about the flags used above with the netstat ps commands with their respective man pages. Yeah, that is again an advisory to understand these utilities better. All right, moving to the next one: persistence mechanisms. And let's see this. Knowing the environment we are investigating, we can then move on to finding what sort of persistence mechanisms exist on the Linux system that you are investigating. Because understanding and finding the persistence techniques are very vital in forensics, because when you are investigating any infected machine, there must be or there might be any sort of persistent techniques that you need to find, and you need to eradicate those persistence to remove the threat actor completely from the system. That is where this persistence becomes very vital. And persistence mechanisms are the ways a program can survive after a system reboot. So that is what the persistence is all about. Even after multiple restarts, reboots, when the user log in for the first time, or when the user logs in every time, it will be starting. It will be persistence in the system. So that is why the persistence mechanisms, detecting the persistence mechanisms is very important. And this helps malware authors to retain the access to the systems even if the system is rebooted. Not only malware authors, even the ethical hackers or not ethical hackers, evenly, sometimes some notorious the black hat hackers can have some persistence on their target. So not only the malware. So that is what they are trying to explain here. And one of the persistence techniques, the popular persistence techniques, is cron jobs. They often create some cron jobs to be persistent on the target system. And to detect the cron tab, you have to view this specific file, HC cron tab. So most of the contents that we have witnessed before were present in the HC location only. So let's see this one too. The same HC location and the file name is cron tab. So here you can see the list of cron tabs, I mean the cron jobs that are already available on the system. And the above terminal output shows the content of the sample HC cron tab file. As can be seen, the file contains information about the time interval after which the command has to run, the username that runs the command, and the command itself. It can also contain the scripts to run, where the script that needs to be run will be placed on the disk, and the command to run it will be added to the file. So here they gave the content of the cron tab. So here is the content of the cron tab. So here what you can do, you can specify any file that has to be executed periodically, and also the run, I mean the user who is actually running that specific cron job, and that also you can find here. That is what they gave. And service startup. So this is another persistence techniques that can be incorporated by the attackers. And we have seen the same technique in Windows operating system too. In Windows operating systems, they can modify some service details, and whenever the service starts, they will be getting the access to that system. So gaining persistence through running services. And in Linux, like Windows, the services can be set up in Linux. Yeah, that's what they are saying. And a list of services can be found in the hc init.d. Earlier, we have seen processes, how to view the processes. We used the ps utility to view the list of processes, and additionally, we used the aux parameter to view the details of the running process. But now we are going to see the list of services that are running. And to view the list of services, you need to view the same hc, and this time the file name is init.d. And let's try to read that. It's a directory actually. So let's try to navigate to the init.d directory, and here we can see the list of services that are running. So here you can see the list of services, and the next one is .bash rc. Uh, Gaining persistence through the .bash rc file is also possible. Let me show how. When the bash shell is spawned, it runs commands stored in the .bash rc file. So this is a typical behavior in Linux. This file can be considered as a startup list of actions to be performed. So whenever a Linux machine is getting started, it will run the content of the .bash rc file. If you are a non-root user, then if you are having a sudo privilege, you must be having the .bash rc file in your home directory, and any content which is in the .bash rc file will be getting executed whenever you are getting logged into the system. This is applicable to the root user as well, and hence it can be proved to be a good place to look for persistence, of course. And you can see the specific user, a normal user, actually denoted the home directory. In the home directory .bash rc file, they are simply catting the outcome, and you can view the list of, I mean you can view the content here by catting that out. So let me move to my home directory. I logged in as a user Ubuntu. So I'm simply moving into the home directory with the help of a simple command cd change directory. Now my current location is my home directory. And now what we can do, let's look for the .bash rc file. When the file name is starting with the dot at the beginning, then it is a hidden file. So to view the hidden file, you need to use the ls-la to list all the content of the specific directory, all the files of the specific directory. And yeah, through this we will be able to witness the hidden files too. And here I I think I can see that bash rc file as well. At the top I found the bash rc file. And yeah, now I got to know this specific directory is having the bash rc file. Now I can cat this out. Dot bash rc. Yes. Now here you can see the content of the bash rc file. All right. Now moving down further, the system-wide settings are stored in the hc and hc profile files. So it is often a good idea to take a look at these files as well. So these files are similar, but when you make any change in this file, this will be applicable to all the users who are accessing that system. So that is why they are calling it as a system-wide setting. So let's try to access this to hc bash.bash rc. All right, cat hc bash dot bash rc bash rc. Yeah, I can see the content. And let's see the another file to hc profile. Cat hc profile. Yeah, here we can see the content. So what a threat actor can do, they can simply gain access to this file and they can add their persistent, they are add certain command to get execute whenever the system is getting started. All right. In the bash rc file, the size of the history file is defined. Okay. What is the size of the history file that is set for the user Ubuntu in the attached machine? Okay. We have initially seen the bash rc file of the Ubuntu user. It is nothing but the dot bash rc. And let's try to see the size of the history file. And I'm simply using the less command. And here you can see the history file size. For the setting history length, see the hist size and hist file size in bash 1. And the hist size is 1000, hist file size is 2000. So that would be the answer, 1000 or 2000. They're asking for the history file, right? So let me give 2000 here. That's the correct answer. Perfect. Now moving to the next one, evidence of execution. Let's see what we are having here. Knowing what programs have been executed on a host is one of the main purposes of performing forensic analysis. For example, let's say you are examining a machine which is suspect to be, which is about to be, not about, which is suspect to be infected by any malware. If it is a malware, then obviously it's a typical behavior of malware to execute certain files. So when you are have to perform these forensics, you have to understand where to look for the recently executed files. So that is where the specific part of this Linux forensics getting vital role. On a Linux host, we can find the evidence of execution from the following sources. All right. So let's see where we can look at the sudo execution history. All the commands that run on Linux host using sudo are stored in the auth log. So whenever the sudo privilege is getting called to execute certain file, then those attempts are stored in the auth.log file. It is again one of the files of var log directory. And we already learned about the auth log in task 3. Yeah, we did. We can use the grep utility to filter out the required specific information. And what they did, they actually try to grep for the word command. And when they grep for the word command, they can witness the command that was executed by the user root. Since they are using the sudo privilege, it is getting executed as root user. And Scrolling down further, bash history, and you can also see the list of commands that was executed. Any commands other than the ones run using sudo are stored in the bash history. Just now we have seen the commands executed using the sudo privilege. Now the commands executed using non-sudo. As a non-sudo, the non-sudo commands getting executed. We can view that in the bash history file, and it is located in the home directory of every user. And that's what they gave. And when examining the bash history, we need to get the bash history file from each user's home directory. It is important to examine bash history file from the root user as well to make note of all the commands run using the root user as well. Perfect. Now let's try to get this bash history, right? So we are currently in the home directory of Ubuntu. All right. Now from here we need to look for the bash history, and I'm simply getting the hidden bash history file underscore history. And here I can see the list of commands executed. And I can also see the same outcome with the command history, I guess. Let's see. There are some difference actually. I gave a wrong statement before. When you see the bash history file, it gives the commands that were executed using the sudo privilege. But when you are simply using the command history, it gives the commands that are executed with non-sudo privilege. Let's look at this one once again. Every command is executed with sudo privilege. You can see it clearly here. Most of the commands with sudo privilege. Yeah, even the cat command used to see the etc password, because this specific file can be viewed only with the sudo privilege. So that's why it is being displayed in this bash history file. And scrolling down further, here you can see some spooky information. The bash history is showing some directory creation, WannaCry, and they are moving some file file with the name ransomware.wannacry to this folder, and they are cding that folder and unzipping that file and removing. Yeah, here you can look at, they are actually trying to extract that malware in that system. Everything you can, when you are gaining access to this bash history file, you'll be able to see each and every command that was executed by the user. And files accessed using Vim. If if your machine is having the Vim editor, then the Vim editor is storing all its commands. All the files that are getting access through the Vim editor in this specific file .viminfo, and you can view that information as well. And that is also located in the home directory. So let's see whether we are getting any content for that Viminfo. I'm cutting out Vim info. Yeah, here you can see the list of files that were accessed using the Vim utility. And scrolling down further, yeah, we are in the question and answer section. Let's try to answer some questions. The user TryHackMe used apt-get to install a package. Okay. And what was the command that was issued? Okay. And you need to check the bash history for the user TryHackMe. So now we are in the Ubuntu directory. Let's move to, actually I became the root. Now I am moving to the home directory of the user TryHackMe. And here I can see the bash history file of the TryHackMe user. And now let me cat this bash history file dot bash underscore history, and here we can see the command that was executed, sudo apt-get install apache 2. Actually the TryHackMe user tried to install the apache 2 web server, and that is what they are asking here. Yes, that's the answer. And what was the current working directory when the command to install nettool was issued. Okay, we have to view the authentication logs here, and you can grep the command and nettools, the working directory denoted by the present working directory. Perfect. Now let's try to get into the, first of all, let me cat this var log auth log. Okay, and I'm adding star because the var log directory will create lot of auth.log file. Actually, when the log content, I mean, when the log quantity is getting increased, it will put every content in different auth.log file. It will be naming the file like auth.log1, auth.log2, auth.log3. So that is why we are using asterisk as a wildcard. And now we are grepping for the word command, and I'm only showing the less outcome. What was the question? Install net tools. So let's try to spot the word net tools. And actually, I again switched back to Ubuntu user, and I tried to execute this command. I'm simply catting the content of the auth.log file with the wildcard mask, and grepping the pattern net hyphen tools instead of command. And here they are asking, the question was, what was the current working directory when the command to install the net hyphen tools? So that's why I'm using this command. And here I got the output specific to the specific, I mean, specific to the command net hyphen tools. And they use the command apt hyphen get install net hyphen tools. And here you can see the present working directory. It was home Ubuntu, and the user root. As they used the sudo privilege, they executed this command as root. And the command they gave here. Actually, the location of apt hyphen get, I mean, apt hyphen get binary is usr bin. So that is why they gave the whole path here, the whole command. All right. Now this is the answer that we need, and yeah, that's the answer. And the next one, log files. So let's see what we are having here. Looks like we have a couple of interesting things. Yeah, one of the most important sources of the information on the activity on Linux host is the log files. Yeah, this is obvious. These log files maintain a history of activity performed on a Linux host, and the amount of logging depends on the logging level defined in the system. Let's take a look at some of the important log sources. Logs are generally found in the var log directory. This is very crucial repository and crucial directory actually, pardon me. And the next one is syslog. The syslog contains messages that are recorded by the host about the system activity. The detail which is recorded in these messages is configurable through the logging level. We can use the cat utility to view the syslog, okay, and which can be found in the var log syslog. And even the syslog file is located in this same var log directory. Since the syslog is a huge file, it is easier to use the tail, head, more or less utilities to make it more readable. All right. So here you can use this utility additionally to read the huge content of the syslog file. And scrolling down further, the above terminal shows the system time, system name, the processes sent, the logs, the process ID, the detail of the log. We can see a couple of cron jobs that is being run here in the logs above. Apart from the other activity, we can see the asterisk after the syslog. This is include the rotate the logs as well. As I said before, Linux will be storing the log files in various names by appending the numbers in the file name. So to view every file, we can simply use asterisk as a wildcard. And with the passage of time, Linux machine rotates older logs in such a file. Yeah, that's what they gave. So whenever the Linux machine rotates the logs, it will use the file names like this: syslog.1, syslog.2. That's why we are using asterisk at the end of the syslog. And you can see the content here as they gave. It is actually running some cron jobs, And apart from that, it is actually performing some stuff. Looks like some DNS resolution attempted, and man DB service, and we can see the cron job that is getting starting cleanup of temporary directory. Yeah, these are the activities we can observe with the help of this syslog file. And let's look at the next one, auth logs. So we have already explored this log file, auth.log, which will actually contain the information about the users and authentication related logs. So here you can see the stuff. So I'm going to use the same command, simply piping out the output to head. So here is the list of users who logged in. This image clearly shows the authentication and user management related activities. And moving to the next one, third party logs. Similar to the syslog and authentication logs, varlog directory contains logs for the third party applications such as web server, databases, and file share server as well. And we can investigate these logs by looking this varlog directory. And if you want to look if you want to look the logs of any specific applications that is running on the Linux system, it can be a web server, database, or whatever. You can use the same. You can view in the same directory varlog, where you'll be able to spot the relevant file name. The log file related to that application. And for example, if it is OpenVPN, here you can see the file OpenVPN. So the logs related to the OpenVPN application will be stored in that file. And Samba, it's a file share in Linux, so related logs will be stored there. And you can see the Apache too. It looks like the web server is running on this machine. So all the web server related logs will be stored in this specific Apache 2 file. So this is how you need to start the investigation. And as obvious, we can find the Apache logs, as I said before. And similarly, if the database server like a MySQL is installed on the system, we can find the logs in that directory. All right. Now let's try to answer these questions. Though the machine's current hostname is the one we identified in task 4, the machine earlier had a different hostname, which was the previous hostname of the machine. We need to spot that hostname. Check the syslog. You can grep the hostname to shortlist the logs of your interest, and check what other hostname was present in the syslog apart from the current one. You can use the syslog asterisk to include the syslog that have been rotated in your search. All right. Now let's try to cat that syslog file content, and I need to grep for hostname. So let's try that. Actually, same, but the syslog files I'm going to see, and I need to grep for host name. So let's try to okay. So here I can see the host name Linux 4 and 6 using the system, but I need to see the old username. Here is the host name. Change the host name to IP-10.10.178.149. This could be the answer. So let's try to enter this. I doubt this. No, it is not the answer. But looks like the host name is TryHackMe. Now let's give this. Yeah, that's the right answer. Perfect. We found the previous host name with the help of the syslog file that is located in the varlog directory. And moving to the conclusion part, look at this file. So far, we have seen so many interesting locations where we can find some crucial info. But here in this image, every detail given in a same page. You can see the system and OS related information. You can view this directory. And any account information, this one. Any group information, etc group. Pseudovers list, etc pseudovers. Log information, login information, varlog wtmp. And you cannot, I mean, you can read this only using the last utility that also given here. Authentication logs, you can use varlog auth and system information, you can view the host name here, time zone here in this file, network interfaces, and the active connections. And another command, ip address show, and the ps space aux to view the list of processes available, yes, hc host to view the dns entry, hc resolve.conf to view the dns server details, and and if you want to see the persistent info, then for the cron tabs, look at this location. For services, look at this HC initd bash shell startup. You need to look for the specific users bash RC, and including the root user, and the system wide bash RC configuration. These are the two files. And evidence of execution. Actually, this file contains each and every location that we have discussed so far. So it is like an overview of this video that we have seen so far. Yeah, this is what all about this room. And with this, we are finishing this Linux forensics. And yes, this is what I exactly wanted to showcase. Hope you have learned something new about the Linux operating systems and its forensic stuff. If you really enjoyed this, consider hitting the like button, and also you can subscribe my channel for new videos. And if you have any other opinion, put it on the comment section. I'll be reading those comments and responding to your valid questions. You can also share this video among your friends on the community. And hope you really enjoyed this. I'll catch you next time with another exciting video. Until then, I'm signing off. Cheers, and I love you all. Thank you so much.